Okay, now I'm recording. Okay, so we are focusing on two types of sequences today. We're talking about something called an arithmetic sequence, and that's how I read it, arithmetic, not arithmetic or anything. Arithmetic is when you add or subtract to go from one number to the next. And we're also going to talk about a geometric sequence, which means that we are going to multiply or divide to get to the next number. It's not actually geometry. I know that it might give you some PTSD, but we use the word geometric to describe sequences that increase by multiplying or dividing by the same number each time. So an example of an arithmetic sequence is something like 1, 4, 7, 10, and most sequences go ... at the end of it. Now my question to you is, what did I do each time to go from 1 to 4? Add 3. What about from 4 to 7? What about 7 to 10? Good. So the reason I ask is that I know you're probably like, that is so elementary, but I ask you that because if it's not the same number each time, yes, it might be a pattern, but that does not make it an arithmetic sequence. It's just a lotto ticket through. You can have mine if you want it.
Actually?
Yeah.
That's right, G. I don't actually want.
If I win, I'll give you half the profit.
Okay.
It's gonna be.
So if it's $5, I can have $2.50.
Or actually, I'll give you 80% of the profit.
Oh my God, you're so thoughtful. Thank you.
I'll give you $2.
Okay. All right. So arithmetic sequence plus 3 each time. That is what we call the common difference. So the number that you add or subtract each time to get to the next one, we'll say D equals 3. Okay. Now the reason I bring that up is because now we're about to do a formula for the nth term. That could be the 10th term, the 20th term, the 500th term, the 15th term, the 11th term. Any number you want, any term you want could be right there. Oh, I don't know what that was. Okay, that formula looks like this. It goes A sub n. What I'm physically saying is A sub, like a subscript n. It kind of sounds like a different language if you don't really know what I'm saying. So A sub n equals A sub 1 plus n minus 1 times D. Those are probably things that you haven't seen or haven't heard of before. Now D we just learned about. What was D again? Common difference. In this case it would be 3, but in general we just call it the common difference. A sub 1 is the first term. So it's the first number in our sequence. A sub n is which number term? Nth. Good, it's just the nth term. So it is the nth term. And then n is the number term we want. So if I want the 17th term, then n is 17. If I want the 5th term, then n is 5. So A sub n and n are two different numbers, and that sometimes is confusing to us. Okay. We're going to use these in a second. Actually, let's just go ahead and use it right now. Let's go do an example with this right now, and then we'll learn geometric. Okay. N stands for the number term you want. So if we want the 4th term, n is 4. If you want the 20th term, n is 20. If you want the 5,200th, then n is 5,200. Okay, so let's go do example 1a, because I promise you that's going to be an arithmetic sequence. So let's go. What is my common difference? What do I do to get from 3 to 7? Plus 4. Is that what I do to go from 7 to 11? And from 11 to 15? Absolutely good. So D is going to be 4. All right, let's read the directions. What does it say for us? It says, tell what type it is. Okay, we haven't learned a different type, so this must be arithmetic sequence. Again, we'll learn geometric in a second. I just really wanted to solidify this in our head. And then it says, give an explicit formula. So we're going to use the formula we just learned, but we are going to simplify it down as much as possible. So this formula right here A sub n equals A sub 1 plus n minus 1 times d. And we're going to plug in according to what's going on there. So A sub n equals A sub 1 plus n minus 1 times d. I'm not super familiar with it, so I'm going to rewrite it. And let's fill in the pieces. Do you know what the first term is? Yep, so that goes for my A sub 1. We don't know what nth term I want yet. They didn't tell me, so I'm going to write n for my nth term. And then d, what did you just tell me our common difference was? 4, good. And then we don't know what our A sub n term is. When I'm writing this explicit formula, it means that we just want to know like what's the general form. In a minute, we'll plug in a number for n and find the 10th term or the 15th term or whatever we feel like. But before we get there, let's simplify this down a little bit. So let's multiply 4 throughout. So A sub n equals 3 plus 4n minus 4. Again, we're just simplifying it as much as possible. And then last, we can add our common terms, 3 and negative 4, and we get 4n minus 1. Ooh, you guys okay with using that formula? That's my explicit formula, yeah. That would be my answer if I asked for just an explicit formula. Now, let's say I asked for a certain term. I did not in this, but let's pretend and we'll make one up. Let's say I said, find the 12th term. Now, what could we do? We could definitely just add 4, however many more times to 15 and then another 4 and then another 4 and keep going until we found the 12th spot. Or we can use our formula and plug 12 in for n. So I can say, all right, A sub 12 is going to be 4 times 12 minus 1. Is that our formula? Yeah, okay. You guys okay with that so far? All right, then we just simplify and solve. So 4 times 28, or 4 times 12 is going to be 48. And then 48 minus 1 is 47. So that means if I were to keep going and add 4 and add 4 and add 4, the 12th number in that set of numbers would be 47. That's pretty cool, right? Yeah. Thanks for humoring me. Yeah, Cam. Yeah, I know the 4 is behind, and that's funny for us in math, but you still distribute it like it was in the front. So I'm going to multiply it by the n and multiply it by the 1. Okay, so that was an example of an arithmetic sequence, and we'll do a lot more, but can we learn geometric so we can kind of bounce back and forth? Sure. Geometric sequence, this time we're going to be multiplying or dividing in order to find the next term. So let's give an example of a geometric sequence. It could be something like 3, 6, 12, 24. And again, I can just put ... and that just means it goes on and on and on forever. What did I multiply or divide by each time in order to get the next number? Multiply by 2. 3 times 2 is 6, right? Is 6 times 12, or sorry, is 6 times 2 12? And then is 12 times 24 2? Nothing I said there was right, was it? Almost. Let's try again. 3 times 2 is 6, right? Yeah. And then is 6 times 2 12? Yeah. And then is 12 times 2 24? Yeah. I'm so sorry. It took me 20 minutes to spit that out. You good, Drew? Yeah. You have a question?
No, Jerron Tibbs got 3 offers this morning.
Wow. Okay, give it up for Jerron Tibbs.
Where to?
One of them was Iowa.
Oh, yeah.
And the Broncos of West Kentucky.
Good for Jerron.
Yay.
Yay for Jerron.
Let's go read
I think
posts.
football.
Any other information?
No,
Yeah.
That's it. Okay.
We don't have to stop and read posts.
You got 10 more seconds.
I'm almost done, don't worry.
9,
It's on
8,
It's
7,
Twitter.
6,
on Instagram already.
On Facebook.
5,
Roger, I'm really eating today. I'm really proud of
4.
myself.
3, 2.
We had cheese last year. There were no coaches.
1.
Like
I'm so
Anthony
sorry.
definitely would have left with the Iowa offer if we actually had coaches last year.
I'm so sorry, guys. All right, that's it. That's enough time on Jerron. Put him away. Bring it back. All right, so we multiplied by 2 each time, right? Now, before we called it common difference when we added or subtracted a common thing, this time with multiplying and dividing, we're going to call it a common ratio. And I know it took me 20 minutes to spit that out, and I know that it like seemed super elementary, bless you. But the reason I asked you, does every time we multiply by 2, does that give me the next thing? Is because if it doesn't, it's not a common ratio and it's not a geometric sequence. So my common ratio here is 2 because I multiply by 2 each time to get to the next number. Okay. Now my formula for the nth term is super similar to the last one. I've got a lot of kind of same players involved. A sub n equals a sub 1. But this time we're not adding, we're going to multiply r raised to the n minus 1. Now this is still kind of new for us. Can you remind me, what does a sub n stand for again? The nth term, good. So the 8th term, the 17th term, the 25th term. What about a sub 1? First term. What about r? Ratio, good, my common ratio. Bless you. And then n's kind of the weird one. It's the number of the term you want. So if we want the 3rd term, 3 goes for n. If we want the 27th term, 27 goes for n.
And is it a circle that was?
No, this is sequences. We're not doing that anymore.
Okay.
I'm not done yet, but
That's a good start.
yeah, I'm going to get breakfast.
Thank you so
I'll
much.
be back to the research.
Okay, I'll be here. All right, so we're gonna go use that and go do an example with my geometric sequences, okay? So let's go down here. The next one, since the first one was an arithmetic, I bet this next one's gonna be a geometric, right? If we're nothing if not consistent, right? -2 to 1. What did I do to go from -2 to 1? Divide by -2. Is that what I did to go from 1 to -2? And is that what I did to go from -1/2 to +1/4? Yes. What's another way to think about divide by -2? We can write that another way. Multiply times -1/2. I want us to always put your common ratio in terms of multiplying because the 1/2 is going to do the dividing for us. So we always put it in terms of multiplying. So that's going to be my r. R equals -1/2. Now, just like the last problem, we're going to write our explicit formula, and then we will find the 12th term as well. So let's go remember our formula. If you forget it above, it's right up here. I'll even highlight it for us. Don't forget this guy. I'm going to carry him down just because we're still kind of new to this. A sub n equals a sub 1 times r raised to the n minus 1. And again, this is the explicit formula, so we don't know what my n is. I don't know what my a sub n is. I'm going to just let it be a sub n, and I'm going to let n just be n. What's my first term in this sequence? -2. Negatives and positives are so important here. Make sure that you carry them through. -2, what did you tell me my ratio was? -1/2. And then I don't know what my n is, so we're going to leave it as raised to the n minus 1. Yeah, Anthony. Great question. So to go from -2 to +1, we divided by -2. And that's the same thing as saying we multiplied by -1/2. Yes, absolutely. 100% I've got a different answer. Yes. So remember, if you are thinking in dividing, I want it to go into terms of multiplying. The other kind of hint that I see here is anytime that I go from like negative to positive and then negative to positive, anytime you're kind of ping-ponging back from negative to positive, you're multiplying by something or you're dividing by something. There's no way for you to add the same number and go from negative to positive and then back to negative. It's always going to be multiply. Justin?
If you see a 1 sequence, can you just use the next number?
Yeah, absolutely. That's a nice little hint. So Justin said, if you ever see 1 in your sequence, can't you just use the next number? Because whatever you did to 1 times anything is itself. So 1 times -1/2 is my r. So yeah, absolutely. It's a nice little shortcut. All right, this is actually as simple as this explicit function gets. I'm actually good leaving it here. I cannot simplify anymore. I'm not going to mess with the exponents. This is good. Let's go plug this in now and do to the 12th term. So we want to find the 12th term. So we're going to say a sub 12 equals, carry everything over. The only thing that changes is that instead of n, we get to write 12. So I do -2 times -1/2 raised to the 12 minus 1. I'm actually going to need my calculator on this because we're about to raise -1/2 to a very big number, aren't we? Okay.
So would you subtract it from 3 power?
Where are we subtracting? Oh, yeah, we can do that. We can subtract that. Do I want to do my -2 times my -1/2 before I raise it to the 11th? No, why not? PEMDAS. I know you're like, Miss White, we learned about PEMDAS in elementary school. It all carries through. It all builds up. And so it sounds so silly, but you've got to remember PEMDAS in order to do PreCalc stuff, right? So we're going to do -1/2 raised to the 11th. So I'm just going to do -0.5. Ooh, let's put parentheses around that in the calculator. Raised to the 11th. All right, I get a really small decimal, and then I'm going to multiply that times -2. And so my answer is a sub 12 equals 0.0009. We'll just go 2 places. 2 important numbers. Cool. Let's think about this, though, if we didn't want to use our calculator. Can we think about how we leave this and do this by hand? If I raise -1/2 to the 11th, 1 gets raised to the 11th and 2 gets raised to the 11th. So that's like -2 times -1 to the 11th and 2 to the 11th. I still have this -2 that I'm multiplying by that. How can I simplify? How can I cancel? There's a 2 on top, and then there's how many 2s on bottom? And now there's going to be 10. And what's -1 to the 11th? -1. Remember, I've got 2 negatives here, so they'll cancel out to be a positive. So I'll have 1 over 2 to the 10th. And I'm going to argue that if I put 1 over 2 to the 10th in the calculator, it should be the same thing as that. I'll even prove it to you. Cool. Magic. Yeah, it can. No. But my job is to teach you guys some number sense. So I want you to not feel like you just are reaching for the calculator blindly. We could have done this by hand. All right. Absolutely. That's mathematically correct. So yes, I will accept that. All right, shall we continue? I know that it says the word recursive function, but I want to hit that another day. I want to focus on the explicit function and really nail that in our heads today, okay? So that means we're actually going to kind of skip a few. We're going to go all the way to number 5. So we're going to skip all of this conversion, divergence. We'll hit that next class. I want to skip to number 5, and we're going to do some more of this exact same stuff. We're really just going to nail it in our heads, okay? So number 5, don't cross anything out. I don't know what we're going to do or not do, but I only have one more day of notes after today, and I'm just really trying to hit the high points right now. So this number 5 says, consider the sequence, find the common difference ratio, the 8th term, and the explicit rule for the nth term. So we got to find a lot of things here. All right, so let's attack number 1. It says 3, -1, -5, -9. -4. Is it arithmetic or geometric? Arithmetic. And I'm just going to abbreviate. Arithmetic sequence -4. What is -4? D. Common difference is -4. Good. So we had to decide what my common difference and ratio, figure out the sequence. Now we have to find the 8th term and the rule for the nth term. So we have to remember our arithmetic sequence. And I actually might write that up here at the top, my little formula, just so I don't have to keep flipping back and forth through my notes. Arithmetic sequence was a sub n equals a sub 1 plus n minus 1 times d. Do you want to find the 8th term first or find the explicit formula first? Let's do the explicit formula first. Does it matter? No. But we'll find the explicit formula first. I think that's pretty easy. So we'll do a sub n equals, what's your a sub 1? What's your first term? 3, good. Plus n, we don't know what n is. And what's my difference? -4. It's not -4, it's times -4. Everybody's with me? Yeah? Okay. Now what? Distribute. 3 minus 4n plus 4. And then now what? Good, -4n plus 7. You're right. I said whoa because my iPad's doing some weird stuff. Did I tell you guys how I bought an Apple Pencil and then I realized it didn't work with this iPad and so I had to return it?
I did that same.
I felt like such an idiot.
Wait,
Nothing has made me feel older than going to buy an Apple Pencil, trying to make it work on here, and then it not working, and then I had to take it back to Target and was like, I'm an idiot. So
why didn't it work?
it's not compatible on older iPads. No, I think it doesn't work on an old iPad.
You might want to.
I don't.
You buy this one,
What is that?
that Apple Pencil with no.
Oh, that's
Oh.
one.
I don't know.
And it's cheaper.
You guys, that's out of my knowledge.
See, I use an all-out pencil, but that one doesn't work. So it's like another upgrade.
Yeah. I'll figure it out this summer, but you guys don't get to reap the benefits. So, all right. Anyway, am I done with this problem? Can I move to the next one? No. What do I have to do? Find the 8th term. Let me actually move this over. Let's find the 8th term. So how do I take my explicit function and find my 8th term? Plug 8 in for n. A sub 8 equals -4 times 8 plus 7. -32 plus 7. So a sub n is going to be -25. Good. I know mental math is hard in the morning, but we got it. All right, we found all of the things. Let's go to the next one. What's going on here? Times 2. Is it times 2 for all of them? Times 2, times 2, times 2. You've got to check all of them. Don't get fooled because you did the first one and you didn't check all of them. Now, which sequence is this? Not arithmetic, it's geometric. Geometric sequence. So what does that make 2? Why is 2 important? It's my R. It's my ratio, yeah. Both things are correct. All right, now let's go find my explicit formula. Oh, let me write it at the top too, just so I kind of have a little cheat sheet at the top. Geometric sequence, a sub n equals a sub 1 times r raised to the n minus 1. Now these are things I will expect you to know. So I will not give you these formulas. Oh, okay, I guess I'm not highlighting it then. All right, let's go plug it in. Remember, my explicit formula for my geometric sequence is actually really simple because I can't really simplify it very much. A sub n equals, what's your a sub 1? 3. And then what's my r? 2. And then raised to the n minus 1. Can I simplify it or is that it? That's it. Whoa, why can't we multiply, Maria? Because it has an exponent, good. All right, now what? Plug it in. A sub 8 equals 3 times 2 raised to the 8 minus 1. What first? Exponent, good. And then times 2 to the 7th. Good, that's not too crazy of a number. Times 3. 384. Very cool. All right, how are we doing? Can we keep rolling? We don't have time for a break today. You have a period and a half left of pre-calc notes, so we can keep pushing. All right, what's going on in this next one? Times -3. Good. Which one is that? Geometric or arithmetic? Geometric. All right. Times -3. I could probably try a little harder. There we go. And so my R is -3. Who can tell me my explicit formula? Tell me. Mhm. Uh-huh. Which is -3. Good. And then raised to the perfect. Great job. That's my explicit formula. Now what? Theo? Perfect. Good. Good. And then we carry our all the way through, and then now it's just some calculator work. I really encourage you, anytime it's a negative, please, please, please put parentheses around it, or you just need to know the rules on when it's positive or when it's negative. So -3 to the 7th will still be negative, times that by -6, and I get negative 13,122. Positive, yes, positive, sorry. Because I did negative times negative.
Yeah.
Thank you for catching me.
You didn't write it down.
I just said it wrong. Yeah, that's true. All right, next one. What's going on? Say what, Chris? -0.5. Which does that make it? Arithmetic or geometric? Arithmetic. Which code did I use before? Purple. -0.5. You're welcome to make it 1/2, or you're welcome to make it 0.5. They're both the same. -0.5, -0.5. So arithmetic sequence. And what does that make? -0.5. That's my D. All right, who's got my explicit formula for me? Chris.
AN equals 10 times plus n minus 1 times 1.
Good. Times what? 0.5?
Negative.
Don't lose your negative. It's important. All right, let's distribute that -0.5 through. Let's simplify it. 10 minus 0.5n plus 0.5. So I get 10.5 minus 0.5n. Did I do it right or did I mess it up? I'm good. Okay. The negatives can be confusing, so you just got to be super careful when you're distributing or when you're carrying those through or adding or subtracting. All right, now what? 8. Hannah, you want to tell me what it is? Did I mess something up? Is this what you said so far? Okay. And then minus 0.5? Oh. Negative point. Oh, okay, okay. I see where you're at. You're hitting me right here at that middle step. That's fine. I probably would have combined my 10 and my 0.5 just so I don't have to add an extra step. That's why I was confused is what you're saying, but you're not wrong. This is fine. I can go from here. So 10.5, so now I will add my 0.5 and my 10, and I'll multiply my negative 0.5 times my 8, which will be minus 4. And then 10.5 minus 4. What is that? 6.5. Thank you. Great. All right, one more like this, and then one more new type of problem. Got some fractions. Does that scare us?
Yep.
No, does not scare us. Scared, it's okay. You're allowed to be a little scared, but we still got to do it. What is my, what am I doing to go from 8 to 1? Good. Both of the things that we said are correct. Times by 1/8 or divide by 8. I would like us to remember that since this is a what kind of sequence? Geometric, then that means that we are going to think about it as my ratio times 1/8. All right, what's my explicit formula going to be? Times 1/8 raised to the, good. Can I do anything to that, or is that as good as we go? Good as we go.
A lot of eights.
Say what?
A lot of eights.
A lot of 8s, because now we're about to plug in 8s, aren't we?
Yeah.
So ace of 8 equals 8 times 1/8 raised to the 8 minus 1. Ooh, lots of 8s. But that 8 minus 1 becomes a 7. You want to do it by hand or in the calculator? Both. Love that answer, Jared. Thank you. Let's do it by hand first, and then we'll check in the calculator, okay? So if I think about 1/8 being raised to the 7th, 1 gets raised to the 7th, and 8 gets raised to the 7th. But we know that 1 to the 7th is just 1, and we can write 8 to the 7th as 8 to the 7th. I'm multiplying that by 8, and how does that help me? My 8 cancels up top, and I can take off one of my exponents on the bottom. So it's not going to be 1/8 to the 7th. It's going to be 1/8 to the 6th. Okay. Now, let's do it in the calculator, and we'll see if 1/8 to the 6th is the same thing we're about to get. So if I do 1 divided by 8, all raised to the 7th, I get this number. What does that mean?
Extra.
Is the decimal in front of this number, or is it back farther in this number? Let me rephrase that question. Is this a really tiny number, or is it a really big number? It's a really tiny number, isn't it? It's essentially like 7 0 spaces, 7 spots are in front of this decimal. So I've got 1/8 to the 7th, and I have to multiply that by 8. So now it's going to get a little bit bigger. This number is like, we'll write it just that far. I have to move the decimal place 6 spaces to the left. So I have to go 1, 2, 3, 4, 5, 6. So it is 0.000003815. So it's a very, very tiny number. Sometimes we get all bent out of shape whenever you see those e's to any power. And I know it looks a little funny on this calculator on the iPad, but anytime we've got an e to a negative power, that means it's a really tiny number. It's almost 0. And let's make sure that's the same thing as 1/8 raised to the 6th. Yep, I get the exact same number. So either way is fine. Okay, I've got another type of problem I want to teach you. Can you flip your paper over? Let me rephrase that. I'm going to keep teaching whether you want to flip your paper over or not. Okay, I want to find the first term in an arithmetic sequence where I give you 2 other random terms. Okay, so this time I didn't give you the first term. I gave you the 4th term, and I gave you the 7th term. So we can think about a list of numbers. I don't know first one or second one or third one, but 4th one is -8. I don't know 5th or 6th, but 7th is 4. So I know those 2 numbers. In the past, we were finding my a sub 4, and we'd be like, oh, my a sub 4 is -8. Or we would find my a sub 7, I'd be like, oh, that's 4. Now I'm going to give it to you, and we have to find both the difference and the a sub 1. We're going to have a little bit of a systems of equations going on in here. Okay? We remember our formula for our arithmetic sequence is a sub n equals a sub 1 times plus n minus 1 times d. This time I have a sub n and I have n, but I don't have a sub 1 and I don't have d. Okay, so let's set up 2 equations. My first equation is for my a sub 4. I'm going to just do it over here just so I've got space. I actually don't need that anymore. A sub 4 What did we say a sub 4 was? What is that number? -8. So instead of writing a sub n, I'm going to write -8 is equal to a sub 1. We don't know that. Plus n. What is my n here? What term is -8? Fourth. 4 is n. A sub 4 was -8, so my fourth spot is -8. So n is 4. So I'll do 4 minus 1 times d. Everybody's okay so far? Great question. It is the fourth spot. I said a sub 4 is -8, so that means that my n is 4. We're going to do it in the exact same way with the other one, so that I'm going to do a sub 7 now. A sub 7. What is your a sub 7th term? What is your 7th term? 4. We don't know a sub 1 still. And then now what term am I on? What's my n? 7. Very good. Minus 1, and we still don't know d. Okay. We're going to find these, and we're actually just going to do a nice little elimination, kind of like we were doing with our Venn diagrams, but let's simplify this before we do it. So I'll do the bottom one since I'm still using blue. I've got 4 equals a sub 1 plus, and what's 7 minus 1? You can do that. 6, so we'll do plus 6d. Having it written like that, 4 equals a sub 1 plus 6d, that feels a lot more like manageable, right? Same thing in the top. I've got -8 equals a sub 1, and then what's 4 minus 1? Good, so plus 3d.
Should 60 that sound like 60.
It does sound like 60, doesn't it? 6, yeah. I'm not even going to say it again because it sounds too similar. Okay, now what I want to do is to eliminate, you need to make one of these equations negative. If I make this top one negative, then that means I've got a negative a sub 1 and a positive a sub 1. So when I add them, the a sub 1s cancel. 8 plus 4 is 12, and negative 3d plus 60 is going to be 3d. What does that make d? 4. Is everyone okay with that systems of equations I just did? Doesn't matter. But since I'm gonna cancel my a sub 1 though, because I only have 1 in each of them, as opposed to my d's, I'd have to multiply by something to cancel those out. Yeah, Theo. Yep, just flipped all the signs on 1 so that my a sub 1's canceled out. Now 4 is equal to d, so let's go find a sub 1. So I'm going to do, it doesn't matter which equation, I'll probably do the bottom one. 4 equals a sub 1 plus 6 times 4. He just came to observe me. You guys acted really great though. Yeah, Miss Coach Vogel was in here.
I didn't notice until I turned around.
You did what?
I thought you were just kidding.
Oh no, he was actually in here to observe me.
That's awkward.
So those of you who like volunteered, great job. Not like you guys don't always act awesome, but what'd you say? No, Miss Son's in charge of discipline.
She did.
Oh, did she observe one of your classes? Oh.
Right?
I know, but he's a STEM director, so he does math too. 6 times 4 is 24, and then we minus 24 from both sides, so a sub 1 equals negative 20. Good.
That's the first.
That's the first term. So 4 equals a sub 1 plus 24. Multiply your 4 times your 6. And then I minus 24 from both sides.
Oh, I was like,
Oh, well, good job. So yeah, so negative 20 is my first term, and then 4 is my d. D is 4. Yep, and let's do it. So if this is negative 20, we're going to add 4 each time. So what's negative 20 plus 4? Good, negative 16. What's negative 16 plus 4? Negative 12. What's negative 12 plus 4? Ooh, that one worked. Okay, what's negative 8 plus 4? Good. What's negative 4 plus 4? What's 0 plus 4? Ooh, that one worked too. Amazing. Okay, I got through C in my other class, but we can do that next class if we would like. And then we'll learn geometric sequence. And then I truly am just going to go through and decide what we need to learn or what I think is most important for you guys to see before the for our last day of notes. So we're going to do a little bit of jumping around next class as well, just because it'll be my last day I'm going to teach you, and I want to make sure that we're doing the most important stuff that you'll see at the next level. So that will be all for today, and you